So the goal of this problem is to try and find a vector that's perpendicular to the plane that passes through these 3 points. So let's take a look at my little Desmos here. Can you see this Desmos here?
Yep.
My Desmos page? Okay, good. So you can think of the plane as being these 3 points. You know, the point at the end of this vector here, the point at the end of the blue vector, and the point where those 2 things meet. So those 3 points define a plane, and you can kind of imagine that with these dotted lines. So we want to find something that's perpendicular to that plane. Now to do that, we first of all need to find these 2 vectors. So let me switch back over to here. And I'm going to find a vector in the direction of P and Q. So to find a vector in the direction of P and Q, I'm going to take the end point and subtract the beginning point. So 6 minus 3, 7 minus 4, and 8 minus 5. And that's going to give me 3, 3, 3. And you could also think of that as 3i plus 3j plus 3k. Now I'm going to repeat that for my other vector. I want something, let's see, starting at P and ending at R. So P, R. So we'll do that process again. It'll be 4 minus 3. And can you tell me what next? What will be next?
So next would be, so we're going from P to
P to
R, right?
R. So 7 minus
7 minus 4.
Good, 7 minus 4, and
6 minus 5.
Perfect, thank you. So that would give me the vector 1, 3, and 1. And again, you could write that as it should be I plus 3j plus k. It depends if you like it with these angled brackets. I kind of like those. This is convenient too. You know, it's just a matter of what you like. But from there, to find something perpendicular to both of these, what you have to do is you have to do the cross product. And the cross product is something that is kind of a unique calculation in all of math. I kind of like it. Now here, I, j, and k are our unit vectors. So I is 1, 0, 0. J is 0, 1, 0. And k is 0, 0, 1. But we're going to take the determinant of a matrix made up of our 2 vectors and this top row here, I, j, and k. So the 2 vectors would be this one here and this one here. So let me put in a 3, 3, 3 here, and then a 1, 3, 1 here. I don't know if it's been a while since you've calculated a determinant by hand, especially by cofactor expansion, but the way it works, you start out at the top row, I, and you're going to multiply by the determinant that you would get if you crossed off this row and this column. So that would leave behind a 3, 3, 3, and 1. And then I'll move over and do the same thing with j. So I'm going to multiply j by the determinant that I get when I cross off the top row and the middle column. So that would be 3, 3, 3, 1, 1. And last but not least, k. Can you determine what I'll be multiplying by here with k?
So it would be 3, 3, and 1, 3.
Perfect, 3, 3, and 1, 3. Now there's one last little detail to remember about calculating determinants by cofactor expansion. That is, you have a plus, minus, plus pattern. So that's a plus, that's a minus, that's a plus. And let's expand these and get some numbers in here. This is going to be I times the product going down is 3 minus the product going up is 9 minus j times 3 minus 3 plus k times 9 minus 3. So I'll get negative 6i minus 0j, I forgot the I there, minus 0j plus 6k. Or you could write it as negative 6, 0, and 6. And so this vector should be perpendicular to both of these vectors. So are you okay with our calculation here?
Yep.
Now let me remind you of an important little fact here. If a vector is perpendicular to another vector, then its dot product should be 0. That is, if I take my vector here, and let's call it vector v, and I take its dot product with PQ, v times PQ should be 0 if they're perpendicular. And if it's something other than 0, then they're not perpendicular. So let's take a look here. Negative 6, 0, 6, dotted with, where was it, 3, 3, 3?
Yep.
Thank you. So that's going to be negative 6 times 3 plus 0 times 3 plus 6 times 3. Yeah, I'm kind of running out of room there, but I got enough. So it's going to be negative 18 plus 0 plus 18, and that's 0. And that's perfect. That's what we were expecting if two vectors were perpendicular. And you can do likewise with V cross PR and verify that that's also 0. I think it's pretty easy to see because you'll have, let's see, negative 6 times 1 is negative 6 plus 0 plus 6 times 1. And that's going to be 6. Negative 6 and 6 again would be 0. So it checks. So the vector that we created here, that negative 6, 0, 6, is perpendicular to both those other two vectors. So that's kind of the cool thing that you can get when you do the cross product. And let me go back here to Desmos. So we start out with these two vectors. You know, here it's called U and V. And when we found the cross product, we got something that's perpendicular to both. Nice. How was that? Is that okay?
Really easy.
You're in great shape for your homework. Yeah. And as you said, Demo,
That was easy.
yes. Cool. Oops. Let's see. I wanted to pause the recording here. Can't for that.